Hi all, I'm Divya Mahadevapa, an embedded engineer at GSAS Microsystems. So today I'm here with a fun and interesting topic. So microcontrollers are usually used for some serious stuffs like controlling motors and reading sensors, but I wanted to try something different. So I turned MCB1700 board into a mini gaming console. Yes, you heard me right. So I developed Sudoku on MCB1700 board. Let us quickly look into how this idea took shape. Before diving into hardware and software implementation, let us now understand what actually the Sudoku is and how it works. So Sudoku is basically a logic-based number puzzle which comes with 9x9 grid, but I have implemented 4x4 grid. When you open a Sudoku game in mobile application, it displays a Sudoku grid with some preset numbers. So consider this numbers in red color as a prefix numbers, and the goal here is to fix the rest of the cells with the numbers without repeating any of the numbers in any rows and columns. So now to implement this on an embedded development board, we should now think, where do you display this grid and how do you provide the user input? Because in mobile application, the grid is displayed on a mobile screen and the user input will be a screen touch or keypad. When I think about this game logic, I thought about Keil MCB 1700, which is based on ARM Cortex M3 LPC1768 microcontroller. So which has the GLCD display inbuilt and joystick, which is 5-way for user input. The reason I developed this 4x4 grid on LPC1768 is because it is easier, simple to handle in memory and perfect for this GLCD display. It also has onboard USB for power, and it also has a support for U-Link Pro debugger for flashing and debugging. Apart from this, I have also added the color coding to our program, where blue indicates background and red indicates if there is any conflicts in the grid, and yellow indicates the preset numbers. Now let us move on to how I built the project in Keil Micro Vision. I have used an example LCD Blinky project as a base, which already has a board support files like GLCD and Joystick included in it. To this project, I simply added Sudoku application file and modified the main function in blinky.c. Files are organized in this workspace, and let me quickly walk you through them. So firstly, we have startup files, which is a standard ARM startup files which has CPU initialization, PLL setup, vector tables, ensuring that board runs at 100 MHz before even your main code executes. Under source files, we have blinky.c, which has main functions in it, which includes GLCD that manages display, everything related to drawing on the screen, and joystick initialize, which handles the user input. Directions are decoded into actions. So then we have Sudoku.c, which is a core logic of the game. This involves drawing the grid, handling the moves, checking for the conflicts, and detecting when the puzzle is completed. This completes the software implementation. Now let us see it in the action. So coming to the hardware setup, I have taken MCB1700 board. I'll now power up the board through USB interface and connect it to my laptop. I'll now connect this U-Link Pro debugger for flashing and debugging. This completes the hardware setup, and now configure Keil Micro Vision project. Now click on options for target and select the device. I have set LPC1768 already, and then switch to target to set the ARM compiler. I have selected use default compiler version 5 for this project, and then switch to debug to select the debugger. Then scroll down and select the debugger of your choice. I have selected U-Link Pro Cortex debugger and select use. Now click on the settings option here and verify the options that you have set for your debugger. I have set normal for connect option and sys reset requirement for reset, and also ensure this verify code download is checked. And then switch to flash download option here and verify this has been selected, erase sector. This option will automatically erase and flash the program every time you start a new debug session. And click on OK and click on OK again. Let us now build the project to make sure it has no errors in it. Yes, we are good to go. And now let us download the project to the board. Yes, the application is running on the board. Here I have flashed the project onto the LPC1768 microcontroller using Ulink Cortex debugger, and the board is powered through the USB port. You can see the 320x240 color GLCD display right here and the 5-way joystick on the right side. This is what we will use to play the game. As soon as I press the reset button, the game starts, and there it is. The Sudoku grid appears on the screen, and it is a 4x4 puzzle with some cells already filled in yellow and others in white for the player to fill. So now using the joystick, I can move the cursor up, down, left or right across the grid. The selected cell is highlighted so you always know where you are. The joystick gives a nice tactical response, and the cursor movement is instant and the real-time input working perfectly. When I press the center button, the number inside the cell increases 1, 2, 3 and 4. Each press updates the GLCD immediately and the display refreshes fast and smooth. Now if I accidentally put a duplicate number in the same row or column, the game detects it automatically and marks the cell in red. This visual feedback makes it easy to understand which move is invalid. So let us now fill the Sudoku grid completely. Once I fill all the cells correctly, no conflicts in any row or column, the system recognizes the completion and shows the victory screen. The display clears to blue and the message you won appears in green at the center. Right now you will see a small golden trophy drawn pixel by pixel using the GLCD functions. And here's the cool part, when I press the center joystick again, the game resets automatically and loads a new puzzle. So you can keep playing continuously without restarting the board. So that's the complete demo of my Sudoku game on LPC1768. Fully functional, interactive and running entirely on embedded hardware. It's not just about the game, it's about how we can use embedded system for creative, logic-driven application combining user inputs, graphics and real-time processing in one simple setup. And honestly, it's pretty fun to play too. I hope you enjoyed watching this as much as I enjoyed building it. Thank you for watching. I'm Divya signing off. See you in the next video.